All right, guys, let's talk about the pH scale. This is probably something that you've heard of. It's very commonly used in acid-base chemistry. Where you have probably heard of this is like on TV commercials or something. You might hear about a shampoo or a deodorant or something that is pH balanced or something like that. You may have heard it, and you may even know that it has to do with acids. It also has to do with bases, and there's a bit of learning to do with this. So pH is a measure of how acidic or basic an aqueous solution is. And this H here, the P kind of stands for like the power of, it's actually a French word, power of hydrogen. It just measures the amount of hydrogen ions that are in a solution. So the more hydrogen in solution, the more acidic the solution is. And then of course, the less hydrogen is present, the lower acidic the solution is, okay? So here's what the pH scale looks like. It's a scale that goes from 0 to 14, with the lowest of the numbers, 0 over here being the most acidic, and the highest number, 14, being the most basic. And so I think the 7 through 14 actually makes sense. You know, we're getting greater and greater in terms of basicity or being basic, but we're actually lower and lower in our hydrogen ion concentration. And then the 7 through the 0, this is each number gets progressively more acidic. And so it's a little confusing to think that the lower numbers mean that they're higher acidic, but that's just the way it works. And there is some math behind that, but we're not gonna get into that in applied chemistry here. So low numbers are acidic, high numbers are basic. And you might be wondering why these lines are kind of curved like this. And that is because this is not a linear type of scale. Yes, like 5 is more acidic than 6, but the reason that this is a curved line is because this is a logarithmic scale, meaning that between each of these numbers, there is a 10-fold increase in hydrogen ion concentration. So each number on the scale is 10 times what the neighboring numbers are. So let's just pretend we're looking at this 4, 5, 6 kind of neighborhood on the scale. 4 is actually 10 times more acidic than 5, and 5 is 10 times more acidic than 6, which means that 4 is 100 times more acidic than 6, and so it's not like 5 is just a little bit more acidic. It's actually quite a bit more acidic than 6 is. So that's the way the pH scale works. Okay, and pH is kind of interesting. It's a really fun thing to do in lab, to use what we call indicators, and indicators are chemicals that you can add to a solution that will change color based on whether the solution is acidic or basic. And we talked about this a little bit when we learned about titration and the use of phenolphthalein indicator. Phenolphthalein is one of a few different indicators that can be used. It's a very common one. But you know, there are these liquids that you just drip, drop into a solution, and they will change color based on the acidity or the basicity of the solution. So here's a list of some of these indicators that are pretty commonly used, some way more than others, of course, but methyl orange and methyl red, they indicate red and yellow in terms of being acidic or basic. And some of these indicators will not just be either red or yellow. They can actually provide like a range, and tell, like, if it's really dark red, it's very acidic, or if it's really light red, then it's not quite as acidic, or very dark yellow means very basic, and so on. Not all of these indicators are sensitive like that, but some of them are. So you can see that we just have this range of colors that can occur with these indicators, reds and yellows and blues. Litmus is a really, really common one. This one does not have a range to it. It's just either red for acid or blue for basic, and it's kind of a fun indicator to use. They're these little strips of paper, and they start out either blue or red. You have blue litmus paper or red litmus paper, and you can, like if you dip the blue litmus paper into an acid, it'll turn red, and if you dip the red litmus paper into a base, it will turn blue. And it's kind of a fun indicator to use. Phenolphthalein we've talked about with titration, and then indigo carmine is just another indicator. And then one that I really like using that's a fun one to use is called pH paper. And it's kind of like litmus. It's paper, it comes in a little strip, and it starts yellow. And you can dip it into a solution, and I wish I had some to show you, but under the circumstances, I just don't have that stuff with me. But you know, you can dip this little paper into a liquid, and it will turn a wide variety of colors from very dark red all the way through very, very dark blue. And then you can hold the colored paper up to a little indexer, and it'll show you exactly what the pH is of a solution. It's really commonly used in like hot tubs and things like that, where people are testing pHs, or you know, fish tanks or something like that. So anyway, pretty interesting to use indicators. Another scale that you need to be a little bit familiar with is something called the pOH scale. pOH scale is not used quite as much. It's used a little bit in conjunction with the pH scale. It's very similar. It's still the 0 to 14 scale. 7 is still our neutral number, where the hydroxide and the hydrogen ions are in equal concentration. But instead of focusing in on the hydrogen ions, we are looking more at the hydroxide ions that may be contributed by a base. When we use the pOH scale. And you know, they're so related that you can actually, like if you take the pH of a solution away from 14, then that number that results will be your pOH. And then maybe even a more simple way to think about these two things is that the sum of the pH and the pOH is always going to give you 14. So the pH is kind of opposite from what the pOH is, and so yeah, there's some questions on your homework that will ask you about pOH, and you'll see that on their unit review as well. Okay, so I hope this helps with pH scale.